Okay, hi guys. So we are getting ready to do 6.3. Yesterday we did 6.2, which was similar polygons. 6.3 is similar triangles. So we have some cool stuff about triangles that we can do with similarity. So the first thing is this postulate 6.1 called AA similarity. If you have two angles that are congruent, you can go ahead and say that these triangles are going to be similar. So that's the first one, by angle, angle. Okay, because obviously we would know that that third angle would be congruent. Um, the next one you have is side, side, side similarity. So if the measures of the corresponding sides of two triangles are proportional, then triangles are similar. So remember, with polygons, we had to check all of the angles and we had to check that the sides were proportional. For triangles, you only have to check that the sides are proportional, and if they are, you can say that these two triangles are similar. The last one we have is side, angle, side similarity. We also had that for congruence, same with side, side, side. So we also have those for similarity. So side, angle, side, just like with congruence, they have to be in order. So side, angle, side. I didn't skip anything. Side, angle, side. If the measures of two sides of a triangle are proportional and they have that included angle is congruent, then you can say that those two triangles are similar. Okay, so let's go ahead and look at our very first example. So in the figure, FG is congruent to EG. So FG and EG. BE is congruent, or I'm sorry, isn't congruent. BE is 15. So for me, guys, when I do this, I actually have to um, draw the two different triangles that I see. Actually, there's probably three triangles there that you guys see right now, and I will show you the third one in just a second. Do you see this little one right here? So I also have triangle FGE, and I know that those two sides are the same. So I know that BE is 15, so I'm going to label that. I know that CF is 20, so I'm going to label that. I know that AE is 9, so I'm going to label that. And I know that DF is 12, so I'm going to label that. Determine which triangles in the figure are similar. So I am looking to use one of these things that we have. So a couple of things. When I look at these right here, I have a little tiny isosceles triangle. Across from congruent sides, I have congruent angles. So I know that angle F is congruent to angle E. Does everybody see that? Across from congruent sides, I have congruent angles. That's the first thing. Now let's look and see if these sides are proportionate. So if I take 15 over 20 and I reduce it, so these reduce by 5, so 15 divided by 5 is 3. 20 divided by 4, divided by 5 is 4. And if I check 9 and 12, they reduce by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. If I get those to be the same, I know that these two sides are proportionate and these two sides are proportionate. So I have sides that are proportionate, angles that are congruent, sides that are proportionate. So I can say yes, triangle ABE is similar to triangle, oh, that's a triangle, not an A. Triangle F, let me rewrite that, that's an issue. Triangle FCD because of side, angle, side. Done. You're good. Okay? Sorry, that was terrible right there. Okay? Easy cheesy, just like we did with congruence. Okay? Next example. Parts of similar triangles. So they're telling us that these two triangles are similar. Notice the arrows, that tells me that these two lines are parallel, which helps me with angles, right? So they would like me to find the measure of AE, and they would like me to find the measure of DE. If I had X Could I figure that out? The answer is yes. We have to make sure we know which sides go together. So we know that this angle and this angle, those are congruent, right? And if I look at alternate interior angles, we know that this angle and this angle are congruent, okay? So by default, then we know these ones are congruent. And I do that, guys, to make sure that my lines, the sides line up. So when I choose my side, x minus 1 over, it's between the 3 ticks and the 1 tick. So when I come over here, in between the 3 ticks and the 1 tick, it's going to go with x plus 5. And it's going to equal, the other side that I have is 2. It's between the 3 ticks and the 2 ticks. So when I come over here, I have 3 ticks and 2 ticks. It corresponds to 5. And this is what we've been doing all week. Okay, so we're going to cross product. So remember, those legs are going to tell us. And when I have an expression, it's really going to be the distributive property. So I'm going to do 2 times this whole thing. And I'm going to do 5 times this whole thing. So 2 times this whole thing and 5 times this whole thing. Now I'm just distributing it. So I have 2x plus 10, and I have 5x minus 5. And now I'm going to solve like I always have. So I'd like to combine like terms. So I want to put all my x's on one side and all my non-x's or constants on the other. So I'm going to subtract 2x. Remember, we talk about there's lots of ways to do this. I get 10 equals 3x minus 5. I'm going to add 5, and I get 15 equals 3x. I'm going to divide by 3, and I'm going to get that x equals 5. Okay? If x equals 5, I can go up here and find AE. AE then equals 5 minus 1, which is 4. And I can find ED, which is, or I guess they called it DE, which is 5 plus 5, which is 10. Okay, so we're putting everything together now. We're creating an equation, solving, going back and finding those lengths, okay? So indirect measurement. This is the last example, and then you can start your homework. Megan was curious about the height of a building in her hometown. She used a 2.5 meter model of the building. Okay, so here is her little tiny model. Okay. And measured its shadow at 1 p.m. The length of the shadow, so here's the shadow on the ground, was 0.8 meters. Now, granted, Magruder needs to figure out how to draw because that's a completely different scale, but that's fine. Then she measured the building's shadow. So here is the great big building, and here is the shadow, and the shadow is 168 meters. What is the height of that building? Well, notice I indirectly gave you guys 2 triangles. Okay, so just like we've been doing, we're going to set up 2 proportions. 2.5 on this goes with that. The height goes with the height. And the shadow goes with the shadow. I'm going to cross product. And I'm then going to go ahead and solve that. So I'm going to do 2.5 times 168, get 420. I'm going to go ahead and divide, and I get 525 meters is the height of that building. Okay, so go ahead and work on your homework, guys. You should have plenty of time to do that today.